All right, the third method for solving systems of equations is elimination. So the past couple days we've been talking about graphing systems of equations when I have two equations and figuring out where they intersect. That point of intersection is called the solution. All right, that was in 4.1c. Last week we talked about substitution, where I knew a variable equaled one thing, so y equals 2x plus 1, and I went ahead and had to plug that into the other equation to solve for y and x. Today we're going to start the third method, which is elimination. A lot of students really like this method because it's easier. It's important that we know how to do all three, but elimination usually is the one students prefer. So it says in cases where the variables in two equations have opposite coefficients, we can solve the system by elimination with the following steps. Step one is to line up the like terms in the equations. Then it would set up the equations to eliminate one variable and solve for the other. You're then going to plug your answer into one of the original equations to solve for the other variable. Write your variables as an ordered pair and check your answer. So hear me out. What they're saying is line up like terms. So here we have our x's and our y's all lined up together. All right. What you're going to do is put a plus sign here and a bar. So what we're going to do is we set it up so that something eliminates. Well, if I do negative 2x plus 3x going up and down, I have 1x. You'll see that this 4y and negative 4y, those eliminate. So I get 1x equals 4 plus 2 is 6, which means x equals 6. Now what I can do is go plug 6 back into one of these equations for x to solve. So I'm going to do this first one. We get negative 2 times 6 plus 4y equals 4. I'll get negative 12 plus 4y equals 4. Add 12 to both sides. And I get 4y equals 16, which means y is 4. So my ordered pair is 6, 4. Same with number 2. Draw a plus sign and a bar. Your x's should be lined up and down. Your y's should be lined up and down. And then the numbers on the other side of the equation. So looking up and down, I see my 6's. My 6 x's are going to eliminate. 2y plus negative 5y gives me negative 3y. And negative 28 plus 4 gives me negative 24. Divide both sides by negative 3. I see y is going to equal 8. Now I need to plug y into one of the equations and solve. So I'm going to plug him into this first guy for y. So when I rewrite that equation, I'll get 6x plus 2 times y, which was 8, equals 4. I'll get 6x plus 16 equals 4. I'll subtract 16 on both sides. So I get 6x equals negative 12. Divide both sides by 6. And x is negative 2. Ordered pair, negative 2, 8. Down below, number 3, line up your variables. Put a plus sign. I see my x's line up, my y's line up, and then my numbers line up. My y's are going to eliminate because negative 7y plus 7y is 0. 4x plus 6x gives me 10x. Okay, 10x equals 30. Divide both sides by 10. X equals 3. I then am going to take that equation and plug it in, or that number, sorry, plug it in for x to one of the equations. So I'll get 4 times 3 minus 7y equals 47. So I'll get 12 minus 7y equals 47. I'll subtract 12 on both sides. I get negative 7y equals 35. So y has to be negative 5. My ordered pair, 3, negative 5. 4. Line up your x's, line up your y's, make sure something eliminates. I see my x's are going to eliminate. So 2y plus 5y is 7y. 18 plus 45, well 8 plus 5 is 8, 9, 10, 11, 12, 13. Carry my 1, so I'll get 63, which means y has to equal 9. Now, I'm going to go back, plug 9 in for y in one of my equations and solve for x. So I get 5x plus 2 times 9, which is 18, equals 18. 5x plus 18 equals 18. I'll subtract 18 on both sides. So I get 5x is 0, which means x equals 0. That's fine. That does not mean that there's no solution. That means that my two equations intersect at 0, 9, which we know is on my y-intercept. Okay? In situations where neither of the variables in the two equations has opposite coefficients, meaning nothing would cancel, like 5x and negative 5x, it may be necessary to multiply one equation by a constant in order to create opposite terms. When multiplying an equation by a constant, remember to multiply each term within the equation. So what they're saying is if I put a plus sign here, okay, nothing eliminates. So what I'm going to do is I see that this is already a negative x. I'm going to multiply this by 2, all right, and change my equation so that now my equation will eliminate. So I'll get negative 2x plus 4y equals negative 26. So what I'm going to do is actually write that equation right underneath here, just so I can see what eliminates. So I'm going to scroll that guy out because I'm done. Now, I see my x's eliminate. 3y plus 4y is 7y. I'll get 7y equals negative 14, which means y is 2. Now I'm going to go back to my equation and solve for x. I get 2x plus 3, y was 2, so times 2 equals 12. So I get 2x plus 6 equals 12. Subtract that 6 on both sides, I get 2x equals 6, so x is 3. My ordered pair then is 2, 3. Okay, looking at this next equation, put a plus sign here and a bar, nothing eliminates. So I'm going to multiply this equation here by 2, so my x's eliminate. So now I'll get 4x minus 10y equals 30, 29, 20. Let's do 40, 38. So negative 38. I'm going to bring this guy over. 4x minus y equals negative 19. And I now know my x's eliminate. My y's, I'll get negative 11y. 8 into 16, 17 equals, that can't be right. Let me see. So negative 19 plus 38 is 57. Let's see, did I do something wrong here? Negative 10. Negative 11. Nope. So then I get y equals negative 57 over 11. Okay, I'm going to plug that back in for x in this equation. So I get 4x minus negative 57 over 11, that's harder, equals negative 19. So I get 4x equals, let's see, when I subtract that on both sides, it's 5.18. All right, and I'm sure you're sitting here rolling your eyes, realizing Miss Versky's mistake. 29 times 2 is 58, not 38. So that would explain why that math did not work. Let's see, let's go back here. This is negative 58, not 38. There we go. So now I should get negative 11y, and that's going to be 58 and 19 equals negative 77, so y equals 7. There we go, much better. I'm going to plug it back into one of these equations. So I get 4x plus 7 equals negative 19. It should be 4x minus 7. That's a minus sign. I'm going to add 7 to both sides. I get 4x equals negative 12, so x has to be negative 3. My ordered pair then is negative 3, 7. Let's check out this next one. Decide what you want to eliminate. For me, I'm going to try to eliminate the y's. So to do that, I'm going to try and get this y to be negative 3. So I'm going to multiply everything by negative 3. I'm going to rewrite the equation down here so I can scribble that guy out in a minute. This negative 3 times negative 3x will give me 9x. Negative 3 times y is negative 3y. And negative 3 times 8, 24. I'm going to scribble this guy out so I know I'm done with them. My y's now eliminate. 9 plus 4 is 13. X equals 8 plus 4 is 12. Carry my 1, 52. divide both sides by 13. And I get 52 divided by 13, which is 4. X is 4. Plug it back into this equation. 4 times 4 is 12 plus 3y equals 28. So I get 12 plus 3y equals 28. I'm going to subtract 12 on both sides. So I get 3y equals 16. Let's see, 16. What did I do? Ooh, 4 times 4 is 16, not 13. That would explain it. So I'm going to subtract 16 on both sides, and I get 12. So y is 4. So my ordered pair, 4, 4. All right. We're going to skip number 8 for now. And I would like for you guys to try to solve numbers 3, 4, 5, 6, and 7 for homework tonight. All right, so these are our notes, our introduction notes for elimination.